Hello everyone! In this video, I want to provide an introduction to web scraping. Oftentimes there's content or data in web pages that you want to extract to use in your project, whether that project be a data science project, a machine learning project, or maybe your own web page or website that you're trying to build. Now, before you do this, I want to emphasize the importance of checking to make sure that the site that you are planning to scrape is okay with you scraping their site. A simple check of their terms of service would be a good start to see if it is okay to scrape data from their website. Assuming that that's all good, then you can begin to web scrape and store that data, perhaps in a CSV file locally or in a database on a server or wherever you're going to store your data so that you could use it for whatever you want to do. Now, recently I've been working on a project where I've been collecting tweets from NCAA college basketball teams. And in order to do this, I needed to first find the Twitter handles or Twitter usernames for all the Division I men and women basketball teams. So I started to do some Google searching to see, has anyone compiled this list? Hopefully that would save me a lot of time since there's over 360 teams for both the men and the women each. And I came across a few sites, and one of them I'm showing here on my screen right now, allmysportsteamsuck.com. They have NCAA Division I football and basketball Twitter hashtags and handles. Kind of scroll through it so you can see. What I was really interested in was this column right here, men's basketball team, to get me started. And I've already gone through the process of scraping these Twitter handles from this column on this webpage and then checking to make sure that they're up to date. And I'll just mention right now that these are not all up to date. And by the time you go and watch this video later, I'm sure even more will be out of date. So the purpose here is not to actually do something with this data, but to see an example of a project that involves web scraping and a simple web scraping example. So essentially, I want to extract all of this data from this web page, put it in a nice CSV file. I'll do that using the Python pandas library, but you can do with it whatever you will, so that later I can use these handles here to get tweets from each of these teams. So what we're going to do is we're going to right-click on this page and we're going to view page source. This is an easy way to see the HTML content behind what your browser's rendering for a web page. So if I kind of scroll down here a ways, you can see we finally get to a table called Rankings Table. There's a T-head here with school, athletic department, football team, men's basketball team, football hashtag, basketball hashtag, and alternative hashtag. And you can see that corresponds to the header row of this HTML table here. If we look, we see the start of the table body, T-body, and then we've got a bunch of table rows, one for each of the schools. And then within the row, there's cell data, TD, tags, so Abilene Christian, Air Force, Akron, Alabama, etc. The one in particular I'm going to search for is Gonzaga. So right here, we'll see table row for Gonzaga. Okay, at Gonzaga Bulldogs. You can see there's actually a typo here. This is not the correct Twitter handle for the athletic department, and then the men's basketball team, and then appropriate hashtags, men's basketball team, and then alternative. So just emphasizing again that just because the data is on a website doesn't mean that it is up to date or correct. You'll always want to check that as part of your vetting process. Okay, so what we want to do is we want to write Python code to make a request to this web page so that we can get all of this content back and we can grab the content that we want and kind of wrangle it into a nice pandas data frame that we can easily write to a CSV file. Not all web pages are going to be as simple as this one. I find it's very often helpful sometimes to, in addition to viewing the entire page source and then just searching through it, to also use the inspect feature in Chrome or whatever browser you're using, so you can easily kind of jump to where this element is in the HTML tree. So I right-clicked on that link there at ZegMBB, and it showed me this is a link in a table data, in a table row, in a table body, in a table, etc. Also, I'll mention sometimes that web pages content are not statically loaded like you're seeing here. It's dynamically loaded, and you'll need to use a more advanced technique that I'm going to show you in this video, but towards the end of the video, I'll mention it so you can look into it should you need it. All right, let's get started. So I've got empty main.py here. All it has is import pandas. I'm going to use this library to store that HTML table data in a data frame that I can easily write to a CSV file. And then I've just got a quick check for if this file, this module is being run directly or not. So I'm going to write a function called scrape team Twitter info. And it is going to make a request using the request library. So I'll need to import requests. If you're not familiar with the request library, definitely check out one of my other videos. I go through how to make basic GET requests using the request library. And I'm going to be making a request to this URL. So I'm going to copy it and I'm going to paste it. So request.get to make an HTTP GET request, passing in the URL. This is going to return a response object. And the first thing I should do with my response object is check its status code to make sure that everything is good. So 200 is okay, the request was successful. If I get something other than a 200, I should probably investigate why. But if I get a 200, everything is good, okay. Now what I want to do is I want to create a soup object from the response text. Now you might be thinking, why soup? What does that have to do with anything? Well, there's this really handy library called Beautiful Soup. So it's a Python package for parsing HTML and XML documents, which is exactly what we're about to do. We're gonna parse an HTML document. So definitely read up on Beautiful Soup. It's a really, really handy library that we're gonna use for web scraping. So here's how we import Beautiful Soup from BS4, import Beautiful Soup. And you might need to pip install this if you don't have access to this package. All right, so I'm gonna make a soup object by creating a Beautiful Soup object, a data structure representing a parsed HTML or XML document. I'll pass in response.txt. This is the payload from our GET request. And then we pass in a string representing the parser that should be used to parse this text. This text should be HTML format, so I'm going to use the HTML parser. So as we go, I'm going to print out various objects so we can get some insight into the variables in the objects that we're working with. It'll help us see what we're parsing where. So let's print out this soup object, and if everything goes well, we should be able to see the HTML content just like we saw in Chrome when we viewed page source. Let's call this function and see what we get. Note that you will need an internet connection in order to run this code because we're making an HTTP request to this URL. So if I print this out, you can see a bunch of HTML. This does look like it matches what we saw in the view page source. So here's Western Illinois, for example. Awesome. So now what we want to do is we want to find the rankings table. And how we do this is we go back to our page source and we find exactly what we're looking for, the specific element. So if I search for the table tag, you can see there's only one of them, which is nice. There's only one table on this web page. It has an ID of rankings table and a style of text align center, and then it has its head and its body, etc. So I'm going to use the soup object to try to find this table. And since there's only one table, I don't need to find all of them and then iterate through them or provide some specific attributes to match to. I can just try to find the table element. There should only be one of them. But I will show you how to be more specific, because oftentimes you are looking for a specific element with a specific attribute. All right, so here's what we're going to do. We're going to call soup.find, and this is where we look in the children of this page element and find the first page element that matches the given criteria. So if there's more than one, this is only going to return the first one. Okay, but you can see that there are a lot of find methods that you can call here. I use find and find all the time. So find all would be like, give me essentially a list of all of them and I'll iterate through them. Find is just give me the first one. And based on our investigation in the page source, there should be only one table, so there should only be one to find anyways. All right, so I want to find table, and then I will print out table. And you can see I get the HTML content just for the table element. Now, suppose that there were multiple and we wanted to be more specific in our searching. We want the table element with the attributes, and I can list them here using a dictionary. So ATTRS attributes, and let's say I want the one with ID rankings table. And I get this from the page source right here, ID rankings table. That way, if there were multiple tables, but only one had this ID, then we would have our soup object go find that one. So we should get the same result here. Just make sure before I comment out our little checkpoint. Great. Now what we want to do is we want to parse the header. So the header contains all of the names of our columns. So what I want to do is find the t-head element in the table. Note that I'm not searching in the entire soup object, just in the table object. So I'll do table.find t-head. There's only one of them right here. T-head, it doesn't even have any attributes. So just searching for this. Remember, we're printing out as we go just to make sure that everything's going well. Perfect. There's our table header element right there. And now I want to go through and grab all of these TH elements and get their text. School, athletic department, football team, etc. So now I'm going to have multiple of these. So I'm going to do THs is assigned thead.findAll, because I want all of them in a list, not just the first one. So notice the hard brackets here. I've got a list of TH objects. So far, so good. Now I'm simply going to iterate through each one and extract their text. This will be the names of my columns. So a little list comprehension here. th.getText for th in ths. And then if I print out column names, I should just see the text for the column names. And there they are. That looks really good. So now would be a good time to pause the video and try this out yourself. Try to parse the T body. So essentially we want a table, which can be simply a 2D list of all the rows in the body. You know what it looks like. Essentially, I want a two-dimensional list where every element is a list with, say, Gardner Webb, comma, at GW Football, comma, at GW MBK, comma, hashtag Gardner Webb, comma, hashtag Gardner Webb, comma, and then blank, empty string, right? This should be one list in the 2D list called table that has all of the contents of this body. So pause the video and try it out. So we'll start by getting the table body. And then we'll get all of the table rows in the table body. And then we're going to iterate through each one. So for table row and table rows. Then we're going to grab all of the table data, all the cell data. So I'll do tr.findAll td. So I'm only looking for the table data elements in this table row, the current one of my for loop. Now I'm going to iterate through each one of those table data pieces and append it to a row. td.getText. After this for loop executes, I should have all of my individual strings for my row, and I can append this row to my rows. Let's print out our rows and see how they look. Should be a two-dimensional list of strings. And it looks good. So here's rows, and then here's the last element of rows. It's the row corresponding to Youngstown State, and second to last, Yale, third to last, Xavier, fourth to last, Wyoming, etc. Cool, I'm going to comment that. And now finally, I'm going to create a data frame. Make sure I'm at the right level of indentation here. So this will be a pandas data frame where I'm going to pass in rows, the table that I just built, and the column names will be my column names list that I created earlier up here when we were parsing the table header. Last thing I'm going to do is set the index of this data frame to be school, since that should be unique for each row. And then I'll return this data frame. Now, note that we are in the body of an if statement if response status code is 200. Well, we can only make a data frame filled with data when response status code is 200. So outside of our if statement here, we should have some sort of fail-safe if something goes wrong when we make our request, like maybe this website goes down, or we've been blocked, or we don't have internet, whatever. For now, I'm just going to return none, but I'll mention that we should do better error handling. Not the focus of this video, but I encourage you to think about this more critically when you're going to be writing more production grade web scraping code for your own project. So now this function returns a data frame, and we can print it out and make sure that everything looks good. So 357 rows by 6 columns. And here's our column names, and the school column is our index. Let's just check our Gonzaga row to make sure that it's good. So let's do df.lock, and was the entry just Gonzaga? It was. So let's see if we can just get the Gonzaga row and it matches what we saw earlier when we were first acquainting ourselves with the web page. So athletic department at Gonzaga Bulldogs, and there's still that typo there. Men's basketball team at ZagMBB, basketball hashtag Zags, alternate hashtag Gonzaga. And it looks like that does match this row, and we've got missing values for our other two columns. So like I said at the beginning of the video, you want to make sure when you start web scraping that what you're doing is valid and ethical. Just be aware of that. Sometimes when you're scraping a website or a web page multiple times, you can get blocked, okay? Just keep that in mind. There are ways to circumvent that, but not the topic of this video. The topic of this video was scraping static web pages. We use Beautiful Soup to do so. If the page that you're trying to scrape is not statically loaded, it's dynamically loaded, you'll know because when you go to inspect the page source, you won't see all the HTML that you expect to see. I recommend looking into a library called Selenium. Selenium could be used to help you scrape dynamic web pages. I'll just put it in the search box here so you'll have opportunity to read more if you would like. All right, that's it for this video. I hope you can now go start web scraping for your own project and build something fun and build something cool. That's it. Thanks for watching.